Welcome to the tutorial on how to calculate heterozygote balance and profile balance. In this tutorial, you will learn analysis of intra-locus balance and inter-locus balance from a dataset when there is a reference dataset available. Multiple file import with automatic trimming of controls and ladders and automatic conversion to the STR-validator format. Adding a die to a dataset and export of results to a spreadsheet software. Start a new session of STR-validator. I'll put the terminal window to the left and the STR-validator to the right. Click the Workspace tab and then the Import button. Click the Select Folder button. Open the folder with the input files. We have 6 files with the sample results and 1 file with reference profiles. Click OK. Expand the Multiple Files option and give the prefix samples to import only the 6 sample results. Check the Auto Trim Samples option to automatically remove positive, negative, and ladder samples. And this is specified in the Trim Options expand group using this string pos, neg, and ladder. Also check the Auto Slim Repeated Columns option to convert to STR-validator format. Give the imported dataset a name. Dataset samples. Oops. And click the import button. In the terminal window, we can confirm that the correct 6 files were imported. Click the import button again, but now select a file and select the reference profiles file. Uncheck the Auto Trim Samples option. Also uncheck the Auto Slim Repeated Columns option. And give it a name, Reference Profiles. And click Import. The 2 imported datasets are located now in the workspace. Click the Balance tab. In the Intra-locus and Interlocus balance group, we have 2 calculate buttons. The first is to calculate intra-locus balance. Click that one. Select the dataset samples dataset and the reference profiles dataset. The check subsetting button can be used to control that the correct reference sample is grouped with the correct samples. Uncheck the Remove Sex Markers option to calculate also for the Y chromosome markers. Uncheck the Remove Quality Sensors because the Fusion 6C kit does not have quality sensors. In the Define Heterozygote Balance As, we have 3 options. We select the smaller peak divided by the larger peak for easy comparison to the MC guidelines. Uncheck the Calculate Average Peak Height option in the post-processing. This option should only be checked if you really need the average peak height, because unchecking this will speed up the process. The kit is automatically detected as the Fusion 6C. Click the Calculate button. Then click the Plot button and select the new dataset samples HP. And the kit is detected as the Fusion 6C kit. Make sure the Do Not Facet or Wrap option is selected. We have different ways to plot the balance data. We start with the HP VS marker. This will plot the data as Boxplot, which is a nice way to summarize the data. Each of the Boxplot has 2 hinges, the upper and lower hinge, which represent the 25th and 75th percentile. The line in the middle is the median. The upper and lower whisker extends to 1.5 times the interquartile range, and all data observed outside this range is plotted individually as an outlier. So go back to the plot window and click the Save as Image button. So I will add a Boxplot behind the name, and then select the PNG image format because that is easily imported into, for example, Word. I will uncheck the overwrite existing file option and also the load size from plot device option. And I will manually specify a size 40 by 20. The resolution and scaling factor can be left with the default. Click the Open button to locate where you want to save the files. I will select the Output Files folder and click OK. Then click the Save button to create the plot. Now select Facet by Marker and Wrap by Die. And select to plot the heterozygote balance versus the height. So this will create a completely different plot where each marker is its own facet. And we have the height of the mean peak height on the x-axis and the heterozygote balance on the y-axis. So we'll save this image as well to be included in the report. Save as image, and I will append scatter to this name. And now the settings are remembered from before, so you just have to click the Save button. And then close the plot window and the plot. Now click the Summarize button to calculate summary statistics. Select the dataset samples HB dataset. Calculate the quantile should be set at the 5th quantile, which means that only 5% of the data will have a worse balance. Summarize by locus and click Summarize button. Then go to the Tools tab and click the Die button to add the die to the dataset. Select the dataset samples HB table locus, and the kit should be detected as Fusion 6C. Add die information and also check the option to add color information and marker order. Click the Add button and click OK to overwrite the dataset. Now click the Edit button and select the dataset samples HB table locus with the summary statistics. So the result now look like this, with the marker, the number of observations, the minimum heterozygote balance, the mean, standard deviation, the maximum, and the 5th percentile. And now also with the added color, die, and order information. If this dataset is small, like it is here, we can use the Copy button to copy all the data and open up as a spreadsheet software like LibreOffice Calc. We can paste the data by clicking Ctrl V and OK. So now we can add additional calculations if we want to. For example, we can add the minimum value, like min, and select the range, and we can also add the maximum value and the range, and I will do the same for the 5th percentile data. And we can do also the same for the standard deviation. And I will add min and max. Okay, so I will select all these number columns and make sure they are numbered. and add one extra decimal, so I have 3 decimals. We can format the title line as bold, and also these additional rows here as bold. Select the top row and add auto filter, and select by marker order to get the data in the correct order. Now we can select all the blue lines and format with the blue color, for example blue 2, and all the green markers, and use the green 2 color. All the yellow markers, we'll use this yellow accent. All the red markers, we'll use the orange accent. And finally the purple, which is only a single marker because the heterozygote balance cannot be calculated for the Y markers. Select the purple 2. So now we have this summary statistics with the nice colors, and I will select all the columns to adjust the width by double clicking in between. So now we can use this in a report for a validation. So we'll save this as in the balance folder, output files, and summary, statistics HP for Heterozygote balance, and click the save button. I will close the spreadsheet software and the edit window and go back to the balance tab. Now we want to calculate the interlocus or profile balance, so click the second calculate button and select the dataset samples dataset. This time we don't need to select a reference dataset, and the difference is if we select the reference dataset, only the correct alleles will be pulled out and used in the calculation. If we don't select the reference dataset, all the detected peaks will be used in the calculation. Using a reference dataset will take a bit more time, so we will speed up the process by not using a reference dataset. And select to calculate the normalized locus balance for easy comparison to the MC guideline. And we do not want to calculate by die channel because we want the whole profile balance to be calculated. Make sure the remove off-ladder alleles are checked, and the remove quality sensors option can be unchecked because the Fusion kit does not have quality sensor. Leave the replace missing data with peak height empty and click calculate. Click the plot button again and select the dataset samples LB for locus balance. The kit is detected as Fusion 6C kit. Select the do not facet or wrap option and click the locus balance versus marker plot option. So here we have all the locus balance summarized in a nice way. And we can see that for this dataset that is based on real casework samples, we do not fulfill the 60% guideline for a good profile balance. But this is perhaps expected, and the profile balance should be evaluated using good quality samples. go back to the plot balance window, and I will save this plot as well. And just add Boxplot and click Save. Close the window and close the plot. Finally, go back to the Workspace tab and click the Save As button to save the project. Locate the folder and click OK. And give it a name. STR-validator balance. Click OK. And then close. Thanks for listening.